Okay, since I'm going to be out, I want to go ahead and record the 2016 4, 5, and 6 FRQ questions so that you could go through those and see some of the tips and tricks that I do with these. So these will be in a series of 4 separate videos. Or 3 separate videos. We're going to start off with question number 4, which is one of our main type of questions that we see as the differential equation. And this is like big points. You can get a lot of points from doing little things that we do all the time in class. All right, our first one is sketching a slope field. This is one that we talked about back in chapter 6. This is a nice, easy question. We just got to make sure that we do the basic math with it. So on the axes provided, sketch the slope field for the given differential equation at the 6 points indicated. So we have 6 points. You want to make sure that you actually put a slope at each of those 6 points. Don't do more than 6 points or they'll actually grade the 6 points or more points that you do. And if you get one wrong accidentally, they're going to take off for that. So I'm going to go ahead and make my table. I always like to make a little table with this. Kind of just organizes all my thoughts. So we have our dy over dx, which is y squared over x minus 1. Okay, that's our dy over dx. So our first point here, 0, 0, nice and easy. We put in that 0, 0 over -1, we get 0. So we want to make sure we put a nice flat line there. And I'll go ahead and do 2, 0, which is going to give us 0 over 2 minus 1, which is also 0. Nice little flat line there. Let's go ahead and do 0, 1. That's going to give us 1 over -1 or a -1 slope. So remember, -1 slope is going to go down. And let's go ahead and do 2, 1. 2, 1 is going to give us, give myself a little bit more room up here. Got to write a little bit smaller. All right, if I put 2, 1 in there, I get 1 over 1, which is going to give me 1. Make sure we get a positive 1 there. All right, last 2, we're going to do 0, 2. That's going to give us 4 over -1, so a -4 slope. Make sure that's a little bit steeper. And then we have a 2, 2, which is going to give us 4 over 1, which is just 4. Make it about the same, positive slope. That's all we have to do. All right. And this one, probably going to be 2 points. All right. And this is an easy 2 points to get. Now, part B, let y equal f of x be a particular solution to the given differential equation with initial condition f of 2 equals 3. Write the equation of a tangent line to the graph of y equals f at x equals 2. Now, we've written tangent lines all year. 2 things we always need for a tangent line. We need a point and we need a slope. Well, here's the thing. We have a point. They gave us the point. They told us that f of 2 equals 3, so our point is 2, 3. And the slope, all we need is the slope at x equals 2. Well, if we go back to the table we just made, at x equals 2, our slope was 1. So f prime of 2 is going to equal 1. So there's our slope, there's our point. Let's do y minus 3 equals 1 times x minus 2. All right, so that's great for a tangent line. All right, this could be 1 or 2 points depending on how they break it down for this particular year. All right, sometimes they'll give you the point for just knowing what the slope is and then the tangent line. My guess is with this one, probably going to be 1 point for just the tangent line, and then they want you to approximate f of 2.1. So f of 2.1, all we got to do is plug in 2.1 into our tangent line. So f of 2.1 is going to be approximately, I'm going to put in 2.1. I really don't need that 1 there, but I'll keep it there just so you see. The only thing is I got to add that 3 over. And because it's a free response question, I'm not going to simplify. I'm going to leave it just like that. And that is great for our answer. So right there, this is probably 4 of our points already. And we haven't done anything that we haven't been doing all year long. So the last piece of this, which is our big point value, usually about 5 points, is find a particular solution, y equals f of x, to the differential equation with the initial condition f of 2. This is our big separate and integrate. All right, so they want a particular solution, y equals f of x, which also means we need to make it y equals. So we're going to take that differential equation, dy over dx equals y squared over x minus 1. So first thing I'm going to do, we got to separate it. So I'm going to cross multiply. So x minus 1 dy equals y squared dx. From there, I can go ahead and divide by the y squared, divide by the x minus 1. So we get dy over y squared equals dx over x minus 1. Now we've separated. You typically get a point if you can separate it. That's great. So we separate it. We got 1 point. Now we're going to integrate it. Your next point usually comes from the integrals. Now, sometimes you'll get 2 points for this. Sometimes you'll get 1 point. But if we integrate this, we can use a power rule. So y to the negative second and use the power rule. So it's just going to be negative 1 over y. And our dx over x minus 1 is going to be natural log absolute value of x minus 1 plus c. Don't forget that plus c. If you got the integrals, that's usually a point, and the plus c is usually a point as well. So now that I have this, I always like to actually go ahead and solve for y at this point. So in order to solve for y, pretty much I'm going to multiply by y and divide by everything else. So if I multiply by y, so I'm going to bring it back up here. So I got negative 1 equals all of that. And then I'm going to divide. So y equals negative 1 over natural log absolute value of x minus 1 plus c. So from there, I need to go ahead and plug in my initial value. So my initial value is f of 2 equals 3. So let's plug that in. All right. 3 equals negative 1 over natural log of 2 minus 1 plus c. Here's the thing. If you plugged in that initial value, that's actually another point. Now, sometimes they group that with the plus c. Sometimes they don't. And that's why it's so important to make sure you remember that plus c and then plug in that initial value somewhere. Well, here's the thing. Natural log of 2 minus 1. We've done that plenty of times. That's just going to be 0. So now I can go ahead and solve for c. C is going to equal negative 1/3. All right. So now you could have gotten that by cross multiplying, by multiplying by c divided by 3. Either one works. So now that I have that, all I need to do is go back and plug it back into my equation to finish this out. So y equals negative 1 over natural log x minus 1 minus 1/3. And there you have it. And like I said, this is probably a 5-point question right here. And a lot of the points, you don't even get the answer. Some of it's just separate the variables. That's usually a point. All right, take the antiderivatives. That's another point. Plus c is usually another point. Plug in the initial conditions, usually another point. And then our final answer is usually the 5th point with this. All right, so make sure we get all those little pieces there. And then just make sure we make it y equals. Okay, and that is the end of number 4.